Hello, everyone. Sorry, it took a little while for this thing to get started. My name is Ted Bendixson. I am here for day 2 of Handmade Hero on the Mac. And if you've been following along, we had a day 1. And on day 1, we went over pretty much exactly the same thing that Casey goes over in his day 1. So it's the process of getting a build up and being able to have a main entry point into an application, or in this case, into our game. And so that's all taken care of. Go ahead and look at the GitHub repository for this if you want to kind of follow along. Once we've got, also remember that our actual application on that first day didn't really do anything, so it's rather boring. It only printed a message. And so what eventually we want to get to is a place where we've got the main, some kind of a window that will then have a buffer that we'll be able to draw to in the game. And this will actually only be on the Mac OS. There's other things we're probably going to add in as well, some sound, that kind of thing. And obviously we want to capture different game controller actions, that sort of thing. So we're definitely going to tap into those kind of events as well. But to get started, the first thing we want to do is get some kind of a window onto the screen. So to do that, though, it's actually, there's quite a bit more that's involved in that process, because not only is it just a matter of getting a window on the screen, the trickiest part is being able to keep the window on the screen. So if you think about it, the application that we wrote in the last session, actually, if you remember, if you run it, it just quits immediately. And the reason that it just quits immediately is because that main application, or that main entry point, is really the operating system will call into that. And then once it's at the end of that function, that's it. Like your app's done. So the tricky part about having a window is also in keeping the window. So that's kind of the thing. That's the thing that we really need to take care of first. And generally speaking, what that is referred to as is the run loop. And so if you've ever kind of worked with any other type of, you may have heard this before actually. So what we're actually going to do is create some kind of an infinite loop that keeps running, that actually receives messages from the operating system. And it's just going to kind of keep processing those messages from the operating system. So some of you who are a little bit more familiar with iOS apps or Mac OS apps, in this case, this comes from an iOS app. So if I were to make kind of a standard iOS app, what I would get in this main.m file, I would have it, it imports UIKit, which is fine. That's kind of Apple's main framework here. And then app delegate. You don't really, that's not something we're actually going to look at right now. We may or may not create an app delegate. We actually don't need to create an app delegate in order to render a window on Mac OS. So, but we definitely remember this. This is pretty familiar. So this is our main function. But now we've got these two things here. So what's going on? So we've got this auto release pool, and this actually has to do with memory management. So an auto release pool, if you think about it, it's releasing things in kind of the Mac OS way is how we talk about dealing with memory and memory management. So if I allocate a bunch of stuff, then eventually at some point I want to release it or free it. So it's just kind of a difference in terms of terms that are used. C and C++, it's known as free. What auto release pool does, this particular kind of declaration, is it says anything inside of it, we're going to free it at the very end. So we're going to instantiate a main application, get the run loop going, and then at the very end we're going to free all of the memory. So we're going to auto release it. We're going to, so anything that you allocated in the process of running your application will then get auto released or freed at the very end. So now there's this, this kind of other thing here. So there's this entire class that it returns called a UI application main. And actually what's going on here is, and by the way, if you were to start up a Mac OS application or do something like this on the Mac OS, you would get NS application main. And so effectively what's going on here is this is hiding your run loop. So you imagine inside of this actual block of code here, inside of this UI application main class, is all of the code that starts a run loop. There's a run loop in there. It's hidden from you as a developer, and it's kind of managing all of this stuff for you. And then what it does is it sends events, application level events, to the application delegate, which is this thing right here. You've probably seen this. You may or may not have seen this before. When the system considers that the application has finished launching, then this particular method will get called. Basically what Apple wants to do is they don't want you as the programmer to like get in and mess with a run loop. They don't want you to deal with that. And for better or worse, in this case, since we're actually like making a game from scratch, I'm going to say that's worse. And actually on iOS, I did a fair amount of research. You can't even really like they don't really offer any like message loop kind of functionality in there that's not like exposed as part of the API, and so you can't actually tap into the message loop itself and handle those kinds of things. So they want you to handle everything either from this application class, or they want you to handle it from view controllers. So view controllers and views, all of these things will actually have ways of dispatching messages from the OS to your application. But if we want something a little bit more custom here, kind of going with the common template that Apple gives you is really sort of not what we want. I think, especially on the Mac, we can get kind of like a finer grain level of control. We can actually take control of this main. So in ours, actually, we're not even going to have any of this code. So we're not even going to have an auto release pool. Like we might later on for other bits of code. We'll kind of get into that. And we're also not going to use this UI application main class or on the Mac, the NS application main. We're actually just not going to use it. And that's because we want to take direct control of the run loop. And so now the question kind of becomes, so we can kind of take a look at that and say, okay, that's kind of what it is. I'm just going to get into our project directory and take a look at where we are. We are now, let's see, I want to get back to the one, okay, this is where we were at the very end of the first day. And so we have this os10 main.mm, okay, and so we've got this. All right, pretty basic and rudimentary here. I'm not really going to use Vim or anything like that because I'm not very fast with it. So, on some level, to keep the application running, we need something like some kind of while loop, right? So we use like while true, right? Do something. All right, but if we were to compile this just as it is right now, you're not going to actually see any, if we were to build and run this just as it is, you're not going to see any kind of output. You're not going to see, even if we did say like allocate a window up here, we will do that. So if we were to allocate a window and show it, that's kind of that's sort of the direction that we're going. Even if we were to do that, this right here is going to block us. Like if you just have this while loop, without some kind of message queue in it or message handling in it, all you're going to be stuck with is an application that's kind of like continually running and not really doing anything. So if we want to kind of get to a place, this is the part where we're like looking up in the API for Apple. Where can we get this, right? So possible candidates. Let's look at let's consider NS application. I'm thinking might actually have what we want. So usually just generally when I'm doing this, I just start looking, NS application. Okay, so just go into Apple's documentation, kind of like how Casey does. So this might give us a bit of a clue into it. So an NS application, this is kind of Apple's class. So we can make an NS application. There's an NS application shared object in there. I usually don't, this is kind of terrible, I don't read all these like introductory marks most of the time, because what I'm more interested in usually is what are the actual, like what's the stuff I can call, what's the actual API look like, that kind of thing. So shared application, it seems like they use some kind of a singleton pattern, which is like we only allocate one of them in memory. It's only got one address in memory, and you can access it. So any application just generally has a single instance of it somewhere. So we've got the NS app kind of global variable for it. So there's actually a global variable for the shared application instance. That's probably going to be important. App delegate's kind of something that we had gotten into earlier, and we may or may not actually use one. We probably will, but we don't really need an app delegate in order to just like render a window. So that's something we can kind of look at later. Now this gets interesting. So, all right, so managing the event loop, right? So in this case, if you're on Windows, it's probably called a message loop, something like that. On Mac OS, it's called the event loop. So what's going on is the operating system is sending events to our application continually, and we're able to then to handle those events. So let's actually, before we go back there, so returns the next event matching a given mask or nil if no such event is found before a specified expiration date. So it seems like the way this works is there's actually like a queue of different events that the operating system is sending, right? And what our app can do then is kind of pop the first one off the top of the queue and get it and kind of keep, process as many of these things as it possibly can. There's other ones, that we can kind of look into. Current event, probably don't need. So these all seem like they're, relatively important things for us to take care of. But the one I think is arguably the most important right here is this next event, matching mask until date. And so if you just go into the documentation, then you'll be given a number of different, this will actually tell you all the different parameters. And what's really nice about this documentation is I can like click on it, and now I can know what an NS event mask is. So in this case, if we look at these parameters, next event matching some kind of a mask. So some kind of like an enum property that's got, and there's a ton of these, by the way. So like look at all these, like mouse down, mouse up, mouse move. So these are all like mouse key down, key up. And think about these. If we want to actually manage keyboard input at some point, this is where we're going to be doing it, because all of these sorts of events are they map to this. So just kind of take a look at scroll wheel. There's a ton of stuff here. So I'm thinking, just looking at these kinds of different events. We're not going to use most of these, by the way. And in fact, in order to render a window, we don't really need to look at any of them yet. So we definitely want this, right? So we want this next event matching mask. And that, needs to go into our, I would argue, inside of this. So we actually have two kind of nested loops. So we've got one loop that is going to manage, that's kind of this outer loop. So every time that we've processed all the operating system messages, then we'll run it again, and we'll process them again, and we'll process them again, and we'll keep processing them. But inside here, we've actually got kind of a second loop. So it's something like do NS app. Actually, what I'm going to do is I'm going to import. I forget what I did in my thing. If I imported, I think it's actually Okay, so this is actually the code, so let's just grab that. I write all these beforehand so I don't have to remember everything. So, so we've got, all right, yeah, oops. All right, we actually don't need this other do. Okay, so, oh wait, actually that's the whole thing. That's funny. All right, so yeah, so this is our outer loop, and then we have the event. Okay. Yep. And then, all right. So, just kind of doing a little housekeeping here. All right. Do, yeah, while event is equal to nil. Oh, and then this is our, okay. Yes. Oh, and that's the switch to, okay. All right. So, sorry, this does not auto format for me. In any case, now we've got this, so there's some kind of event that we've got here. And all we're doing is we're just continually looping and pulling this, we've got this pointer of this event. So we're just pulling off of NSApp. And NSApp, as we looked at in the documentation, that matches, that's what Apple says is the global variable for the shared app instance. So our application, there's only one of these things, and we can just use this NSApp instance property to just grab the events off of it using this next event matching mask. And so NS event mask any, that's going to give us all of them. And then later on, we can kind of filter through the different events. And then, there's just all these kind of other parameters. So we obviously want to kind of keep running this thing forever. So we definitely don't need to, like any, we don't want to limit sort of our time for this thing. That wouldn't make much sense. Default run loop mode, let's definitely like take a look at that and see if there's any other kind of, any other way that we could, do that. I looked at it and it seemed like that was really the only one. So, all right, so that you click on this. So we got some different run loops possible. So common modes, default run loop, mode to deal with import sources, inputs other than NS connection objects, tracking. Okay, so like a lot of these don't seem to be matching up to what we want. Like I don't think we'd be tracking them modally. Maybe come back to that. When waiting for input from a modal panel, so none of these really seem to make much sense. While tracking and control takes place. Add timer. Yeah, I mean, if you just look at these, like none of these really, make much sense. So I think we're gonna go default. Default seems pretty good to me. And then this DQ flag. So again, we can kind of like read more about this. Okay, which timers? Specify yes if you want the event removed from the queue. And so yeah, we definitely want DQ, because if the event isn't removed from the queue, like so what we're saying with this DQ flag, which we've set to true, is remove it from the queue. Like we are the ones that are going to process it, not something else. We're not just peeking at it. We're not just like taking a look. Like we're the ones processing it. So we definitely want that. All right. So what do you think happens if we were to say, and also we want to like, maybe put our statement, finish running. Okay. Now we actually can't build this yet. The reason we can't is because we need the libraries that have NS event, NS app, all of these kinds of things that we're actually using. So one of those libraries, well, that library is known as AppKit. So in this case, let's just include AppKit. Okay. I know. Definitely have to look at my own notes because I don't. This is I'm actually fairly new to this, so I'm just doing the research and kind of presenting it. So it's not only can you just show AppKit, but you also or use AppKit, including it in here. That's actually not enough when it comes to compiling it, because we need to include that framework as a part of the compilation process, and there's a number of different ways that we can do that. We have the ability to include that framework in the actual build command itself. So let's see. Sorry, getting all my work stuff out. Okay. Where was I? Actually, no, wait. Oh, that's right. All right. All right, we want handmade video tutorials, and then okay, so here we are. Now we're back in our directory. I'll do this next time so we don't have to like go through it. And then now we're back at our build script. So if we go to Vim, I'll use Vim for this. So excellent. Somewhere in here we want to include some kind of a place where we want to have our frameworks. So one of the commands that you can do is actually if we go back here, this framework AppKit. So if we actually include -framework AppKit in our build script, say here for example, and let's definitely we'll just hit :x to X out of Vim, and then let's see if we can build this. Okay, so that built, and that's okay. It's probably not the most ideal way of doing this build script. In fact, we'll kind of go over that a little bit in a little more detail as to why that might not be the best. But if we just run this, okay, right now you see that we have not exited. So we do have some kind of a run loop going, but we won't get the exit message until the app actually ends. And so I just force quit it by hitting Control-C. So we're definitely kind of running and processing events, but obviously nothing is showing up on the screen. And there's another kind of thing that I think we probably want to do with our build script. So one thing is, I think it's nice to, if we just do vim build.sh, I think it's nice to have our framework stuff somewhere else, because as you can imagine, as we add more frameworks here, this bit is just going to get it's going to get really freaking long, and it's going to be framework this, framework that, and it just kind of turns into one giant compile command. And I think it'll be better if we actually take that and start moving some of the stuff into variables. If you use makefiles or anything like that, you're probably used to this kind of a thing. But this is, again, we're kind of going the hardcore, purely handmade way of doing things. So actually, as part of your shell script, you can in fact declare your own variables. So OS10, we'll just call it linker flags. Okay, and then just -framework AppKit. Another thing that's so, and then we can now we're in insert mode, so we can just delete all this, and then we can just go $symbol OSX, linker flags. Okay. I hope I did this right. As it turns out, this spacing is really important here. So I tried to do it with like a space from this variable to the equal sign, and then a space between the equal sign and it doesn't interpret things properly. So no spaces here, just so you know, if you want to do any of these kind of variables, it's absolutely not allowed. So sh build.sh. All right, and that produced pretty much the same thing. So again, all we did is we just kind of clean this thing up, because we're going to add a bunch of other flags here. We're going to add a bunch of other frameworks. You know, a bunch of stuff is going to get put here, and we'll be able to kind of keep this compile line, you know, compile command in a nice single clean line. Anyway, so that is good. Don't need to do anything there. And now we're just kind of thinking about, all right, so this is great. You know, we've got you know, some kind of an event loop. We definitely want that. But we're also using AppKit, and AppKit, as a matter of fact, includes our window class. So we can make a window using AppKit. And if we kind of look into this, the class for that is NSWindow. So if we just start typing NSWindow class reference, we can get into Apple's documentation. And so we need to actually make one of these window things. So we're just gonna make one actually. And so what's our possible initializer here? Seems like okay, so we've got window with content view controller. We're actually not going to use view controllers at all, and the reason is because we're just going to be taking some information from the game and having it render to a buffer directly to the window. And this actually seems like it could be init with content rect, style mask, backing, defer. I'm not sure what the screen thing is here, what that's all about. An NS screen. This seems close to what we want, but it might actually have an extra parameter that we don't need. The screen on which, well, nil the content. Specifies the screen on which the window is positioned. The content rectangle is positioned relative to the bottom left corner of the screen. I don't know. I'm going to kind of defer to the one that doesn't have really as many parameters. So this init with content rect, style, mask, backing, defer. So again, just as with many of these things, just kind of read the documentation. And I learned to make iOS apps, believe it or not, by just reading the documentation. So there's a ton of value in just, you know, taking the time to do this kind of thing. So what do we got here to make an NS window? By the way, the language you're using is Objective-C. I might at some point also do kind of an Objective-C primer for people who are interested. Just kind of, you know, like and subscribe, and also at the bottom, just kind of let me know if you want me to do something on Objective-C as well, because if we get back into, you know, this particular kind of like square bracket syntax is very Objective-C kind of way of doing things. So that all this syntax, this is, you know, this is like C. But it also includes, it's a mixture. That's why we have this MM here. So we're mixing and matching Objective-C and C. So in any case, that's just kind of a quick introduction to Objective-C. But we're using this particular Objective-C style method. So returns an instance type. In this case, it's going to return an instance of NSWindow. And content rect. So just kind of reading these things, origin and size of the window's content area and screen coordinates. So I like this kind of funny note here, like, oh, don't, you know, put the window like at 16,000, you know, points away. Like, you know, it's just obviously some like, I can't imagine what sort of a screen would be rendering this thing, or you know, don't have it have 10,000. So definitely some limitations there we might be concerned about. Okay, so then we can kind of get on into all this other stuff. a lot of this stuff is relatively self-explanatory, but the big thing is like figuring out like how do we want to present the window? In what sort of a content rectangle do we want to do that? So we would then we would create an NSRect of some kind, and we call it content. We call it window rect. I know I do kind of this camel case style. Not everyone does that, so I think it's NSMakeRect. Hang on. Let's see what I have here in my tutorial. Yep. Okay, and actually let's just kind of get the default window thing in here too. So we'll definitely put, because we're going to be using this. So this is just our block of code to initialize a window. But before we can do anything with a window, we need to have the content rect. So definitely going to be important there. So let's get that. And we can fill in these other values. So I think it's NSMakeRect is. Oh yeah, that's right. So we definitely want the screen. Definitely want that. Yeah, it is NSMakeRect. Okay, cool. So an NSMakeRect is going to take some different parameters. It's going to, I believe, take the X, the Y, the width, and the height. And so all right, so if we're, it's a little bit weird because if any of you are used to doing iOS application development, some of you might know that NSRect and UIRect are actually kind of different, or rather the way that Y coordinates in particular are handled on the Mac are quite different from the way that they're handled on, say, on iOS. So it's kind of like a matter of top to bottom. It's top to bottom on iOS, but on the Mac OS it's actually bottom to top. So if you position something at 0, Y coordinates, then it's like going to be on the bottom of the screen, and then it goes up. But in this case, big things to consider, because what I think we want actually is not necessarily to put the window. So what this is saying is like, where do we want to put the window? So what's kind of the starting position of the window? It's X coordinate, it's Y coordinate, its width, and its height. I think for now, just to start getting something here, we probably want to have some kind of like a global variable for the window rendering width and the window rendering height. You can pick anything you want for this, really. You don't really need to follow what I'm doing, just kind of whatever makes sense for you. And so I think just something like a static float, global. And by the way, this is totally taken from Jeff Buck's repository, but I don't mind. So 1024 width, and then we'll do another one that's static float for just global. Okay, global rendering height 768. Okay, so we'll just feed these in here. Global rendering width, global rendering height. Okay, and then the X coordinate and the Y coordinate. Really what we want to do is kind of position this thing so it just is in the middle of the screen. And so actually what you can do is just take, I don't remember the formula exactly, but yeah, you take the width minus the rendering width. Yeah, so first thing to do, we would need to figure out how big is our screen. So this actually, if we kind of put this in. So what this does, there's another class called, again, this is kind of this Objective-C sort of brackets. So what's going on here, you can think of these brackets kind of like dots, like dot syntax as you would in C or C++. NSScreen, main screen, that's obviously your entire screen on your system, on your Mac. And then so NSScreen has a property called main screen, And this whole thing, main screen, this like instance of NSScreen, has another property called frame. And so what that is it's kind of like the, this bottom to top width and height rectangle of whatever screen you happen to be using. So in my case, I'm on like a iMac Retina, and so it's actually using that entire kind of screen for it. So we want to figure out how do we get to the middle of the screen. I don't actually remember the formula, so yeah. So what I have here is screen size, the width of the entire screen minus your Windows width, and then half of that is going to kind of give us our x coordinates. So that kind of makes sense. Sort of, I guess I sort of have to puzzle over that, but yeah. So it's kind of like this, like it's going to be some kind of like an x offset from this side of the screen or whatever. So let's do that. So yeah, so screen rect width, actually width, I think it's dot size dot width minus global rendering width, and then multiply by 5. And then the y is going to be screen rect dot size height minus global rendering height times 0.5. Let's see if I got that right. Yep. Okay, so it's like half of the, half of the kind of space that's left over if the entire screen, that's like the offset is kind of what this is. It's like the offset is half of whatever space is left over. Okay. And so that's kind of going to be our frame here. And so now what we can do is we just take our window rect and we plug it in here. So we've got that. All right. Now the style mask is kind of an interesting thing. So if we look at Apple's documentation, NSWindow style mask, this mask is actually one of these kind of things like a bit field. And so it's, if we OR a bunch of these different things together, then we will get kind of, it's kind of like an option set. It's a number of different extra options for how to render a window. So if we look at the style mask, there's like kind of features of the window that we may or may not want here. So do we want, maybe we want it borderless, maybe we want it to have a title, maybe we want you to be able to close it. Maybe you want it to miniaturize, resize. I definitely think we want something like that. Okay, and so you can do like full screen window, etc. There's a bunch of these that we can kind of OR together. I'm gonna kind of pick sort of what's probably more simple. So yeah, titled, closable, miniaturizable, resizable. So we'll definitely want those. I just have like OR sort of within each one. So it's just all of these different kinds of things are going to represent our style mask. We want all of them. So titled, closable, miniaturizable, resizable. Okay, so when we see this window, we should kind of expect a few things to kind of pop up. And then, yep, so our backing store type. Now this kind of, yeah, so let's go back into that and just take a look at what's going on with that. All right, so again, just kind of read what your possible options are, and here, like this is an excellent example where just like having the documentation kind of helps us out, because it's kind of obvious like what we're not going to do, right? So it's almost like you kind of have to laugh at this, because it's like, okay, Apple, well, obviously we're not going to use any of these other ones, so anyhow. We want buffered, so let's use NS backing store buffered. Yeah, backing store buffered. Okay, and then this defer flag. What's that all about? Let's figure it out. Okay, I think I remember. So if we just read the documentation, whether the Windows server. By the way, this Windows server thing is going to sound really strange because, you know, some of you might be thinking, what is there like a server on the internet that's, you know, coordinating with the? No, it's actually just if you like open up terminal or not terminal, sorry, activity monitor. There's like some Windows server process that I believe is like an OS process that is just kind of managing like how windows get created, how they get destroyed, where they move, etc. So there's this Windows server thing. When yes, the defers creating the window device until the window is moved on screen. I'll display it. This probably isn't that important, but I am just kind of like thinking, let's not defer it. Like what? There just doesn't really seem to be much of a reason to. So I would kind of just want the window to just like appear on the screen. Okay, and so this no thing, what's that all about? So actually in Objective-C, because Apple likes their very human sort of language way of talking about things, instead of, you can actually replace yes and no with true and false. So it's kind of just a neat thing to know that you can do. So we have a window. Now, just because you allocate a window does not necessarily mean that you. So if we were actually to build and run this thing, allocating the window wouldn't really do enough for us. We would need something kind of more than that. We actually need to do a few things. I think one of the things that we want to do is, first of all, like give it a background color. Just because we want to. The reason is we want to be able to see kind of what's coming from our game and what's what the just versus the background of the window. So we sort of want to know if it's sort of for debugging purposes. So if you can call a set background color method on NSWindow, and then there's another class called NSColor, and I think you can just use like red color. I'll have to like take a quick look and see if that's what I actually did. Yeah, so NSColor, red color. And another thing you can do is you can set the title, so we'll definitely do that. So we'll set the title to Handmade Hero. Again, the reason that we even can set a title is because of this flag in the style mask that we set earlier. So we gave it this ability to have a title in the top bar through this style mask. So that's neat to know. And then this is crucial. So make key and order front, right? So what's going on here? Well, this make key thing, that kind of sounds weird. Like, and it actually, if you've done iOS development before, kind of in the older days before Swift and before we kind of had. By the way, like iOS development right now, so much of it is abstracted away from you. You know, you never create a window, you never do any of this stuff. It's all just kind of whooshed under the rug with at UI application main. But basically what the key window is, it's the primary window that is receiving keyboard presses. So you think about that, this, for example, right here, the window that we're doing our code in right now, this Xcode window, is the key window right now. It's the key window because it receives keyboard events. I can type, right? Or you know, now this is the key window because it's receiving. You know, I can go in here and I can type. So that's what it kind of means to make a window key. And Apple just kind of decided that they wanted to sort of combine that all into a single API. So not only are you making the window the key window, you're also putting it in front of everyone. So make key and order front. And that is what really presents our window or puts it out in front of everyone. So, all right, we have a window. I know it's not you know, fabulous by any of the stretch of the imagination. Not only do we have a window, we also have a run loop that will process events. It doesn't process any events. In fact, it does nothing for us, but we have a window. So let's actually just see if we can build. I'm hoping so. Okay, cool. So we can definitely build that. And if I go back into our build folder and we run this, ta-da! Now, that window is covering my face, but you can move it around, you can do all kinds of stuff that you want to do, and that thing just renders, right? Now, there's a few issues with this right now. One of which is you can close it, like it's totally closable, and I close it, but you also notice now I've got this kind of terminal window open. There's really nothing that is handling that event. Like, I think what we actually want is when you close the window, the game closes too. So how do we do that? How do we kind of interrupt our run loop or make it so that the game will close when you close the window? Because we're not seeing the, if the game actually closed, we would have seen the Handmade hero finished running message in there, and we didn't. So let's hit Control C. All right, so we just kind of like quit that, got out of it. So, all right, well, we definitely want to do something more than just that. So, okay, so now there's a few things we kind of know about this run loop. So, and this is an interesting thing to know because you typically never see this when it comes to making games or applications. If you do Mac OS app development or iOS development, you know, it's kind of this like, well, what happens when somebody force quits an app? You know, I like double tap on my phone or whatever, and like I whisk the window away. Like, what actually is going on? Like, why is it? How is it that the process like quits? Well, we know that. So first we get like this message processing loop. That thing, if we didn't have this outer while loop here, that inner message loop right here, it would run as long as there are messages in the queue. It would empty the OS queue of events or whatever, and then then the app would just quit. This outer loop is what keeps us running the application. And so actually, if we want to quit the application, we need to have a way to bail from this loop. So right now, what we're doing is we've got just while true, right? So that's an infinite loop by definition. But what if instead we just decided that we wanted to have like a static bool just called running, right? And then we just say equals true. Okay. And so now we replace that with our own kind of method here, or our own variable. So now what's going on is the main event loop, the main run loop, is tied to our global property here. And so if we ever set this thing to false somewhere in the code, you know, triggered through some kind of event, then we will have the game quit automatically for us. So okay, well, that's kind of a part of the puzzle, right? So we've definitely got this this global running property. But now the other part of the question, part of it is there's probably some part on this window that we want that's going to handle a close event for us. So where is that? And so to find that, you know, we kind of let's go back to our NSWindow documentation. Okay, and so there's going to be some kind of some information we'll want to figure out about how to handle things. We can kind of we already did some parts here, so we definitely set the background color. None of this stuff really seems like it's important for what we're trying to do. And this is another one of those things where if you didn't have someone telling you, you know, to look there. Now, again, if you've done some iOS development or Mac OS development, you will be very familiar with the delegate pattern. And so this kind of delegate pattern is this idea of I'm a window or I'm a thing, and I've got something that I want to be doing some work for me. And so it's kind of my delegate. It's my, you know, I say, you know, you handle that little thing and go off and do your thing, and I'm gonna, you know, handle my stuff. So in this case, we have every window has some property that conforms to this NSWindow delegate protocol, or it's this kind of like an interface for delegating stuff out to a window. So we probably want to look at that, probably want to see, okay, well, what does an NSWindow delegate do? And now we're going to get a ton of different events, different things that, so this is kind of our little taskmaster, or that the window, or like the Windows kind of slave or whatever, that it sends off to go and do a bunch of stuff. This window has kind of this long list of different things that it is gonna that its delegate could possibly handle. So positioning sheets, these probably not important. Window will resize. We're definitely going to want to take a look at that later on, because that's actually going to, we probably want to tap into that event at some point, because when we do, we'll be able to kind of resize the content in the games window. So these are all definitely important things. Window will miniaturize. There's probably some state you would want to save, etc. Window will use standard frame. Window should zoom. So a lot of these are kind of not super important. Custom windows to enter. Start custom animation. Okay. Window will move. Window did change screen. All right, and now we're kind of getting to where where I think we really want to be. So closing windows, right? So this is actually this is the action that's mapped to what happens when you click on the red X button in an NS window. So window should close. This might be it, but it's actually, I think what this is like the system is going to prompt you to, so let's actually just take a quick look at this, the character of this method. So it returns a Boolean. Window should close. So, and then this sender pointer it just gives you a pointer to the window that sent this particular message, or sent that requested that it's going to be closed. So the fact that this returns a Boolean is kind of an interesting thing. So what I think is really going on, and also, by the way, this description is really useful too, because it tells the delegate that the user has attempted to close a window, or the window has received perform close message. So what's really going on here is the window's kind of telling you, hey, I think I might be about to close. Or someone wanted to close me, but I'm not sure if I should actually close or not. Can you provide me some guidance? If you return true, because remember this wants a Boolean, then the window is going to close. If you return false, then the window is going to stay open. So it's kind of this intermediate handling of what happens with the window. So I don't think we want that. Window will close, I think, is something that's a little bit closer to what we want. So tells the delegate that the window is about to close. All right, so we know now that our window does close, right? So what's going to happen is, now when somebody taps that red X or whatever on the window, the window is just going to disappear, and we want to be able to intercept that message and do some other stuff in addition to it. One of those things being just exiting out of the game. So I think this is actually what we want. All right, so it's kind of one thing to know that we kind of are on to sort of the thing that we're interested in, but on another level, okay, so we get back to this NSWindow delegate, right? So a protocol, right? So this is called a protocol. Some of you may be used to this kind of a thing in some other languages. You may have heard of this as an interface is another way to describe it. What it is it's kind of a collection of functions or methods in this case, because we're dealing kind of with object-oriented programming, that a thing has to implement. So if I say this object conforms to this protocol, what I'm saying is it does these things. Now, some of these are actually optional. NSWindow delegate actually has a number of different things that you don't necessarily they're methods that you don't necessarily have to implement. You can if you want to, but then some of them are also required. So part of it is guaranteeing a particular interface, guaranteeing a particular kind of a set of behavior. So generally what you do with protocols is you say, all right, so what I'm going to do is I'm going to make kind of a custom object of some sort. So let's do that. So we're gonna define kind of a custom object, and because this file is sort of a combination of Objective-C and also of C, we can write Objective-C right in this file. So we can do something like @interface. Okay, and you see that we're getting kind of the helper text Objective-C class declaration. So we'll call this like Handmade window delegate, right? And its type is NSObject. And the reason that its type is NSObject is because NSObject is the base class for anything in Objective-C. Everything, any kind of a class in Objective-C automatically inherits NSObject. It is an NSObject. And this bracket means that it now conforms to a particular protocol. So not UI1. NSWindow delegate. Okay. So all that we're saying is there is some type called a handmade window delegate, and it's an NSObject. It conforms to NSWindow delegate, and then @end just kind of ends our interface declaration. So something to know. So in Objective-C, you might think about this if you're doing a class. It's kind of like this is what would usually go in the H file. It's sort of the public interface for this thing. And then this @end just says, okay, that's the end of our interface declaration. And then we do @implementation, handmade window delegate. Okay, and it's actually kind of nice because it gives us these sort of kind of fills it in for us. All right, so this is actually the meat. This is where we're going to start implementing some of this protocol. So this is where we want to use our window will close method. So we'll just do that, and we will just be really sort of boring here and copy it directly from the documentation, like so. All right, so now we've got window will close, and you're going to kind of laugh, but really all we're going to do is just go running equals false, right? So what's going on, right? So now all we've done is we've got this global variable, and that's kind of our main run loop. As soon as we set this thing to false, well, this thing is running and running and running and running and running, and then all of a sudden this gets set to false, so it breaks out of the main loop, and we finish the main function. Effectively quit the app, right? So that's what's going on here. This just keeps kind of getting messages and getting messages and getting messages, and all of a sudden, boop, over here, at some point, this window should close, or window will close thing gets called, and that's that. Now, it's not enough to just kind of define this custom object that is sort of our handmade window delegate. So here we're defining it, but we actually have to create one of these things. So in order to make one of these things, we need to be kind of down here. So we just say handmade window delegate, pointer declaration, window delegate equals handmade window delegate alloc init. We're not passing anything into the initializer for it. It just is a flat kind of initialization. And then we just say window set delegate, window delegate. All right, and all that's doing is saying, because remember that NSWindow has a property. If we go back, NSWindow has a property that is the delegate. No, that's actually now this NSWindow delegate. Okay, so here we are. This is the NSWindow kind of class reference stuff. So it does have a property. It's called the delegate. all this like ID NSWindow delegate thing means is ID just means like any instance of a class, any kind of a thing that conforms to the NSWindow delegate protocol. So in this case, we could have defined a bunch of other things that conform to this NSWindow delegate, but we didn't. We only have one thing. So we have a Handmade window delegate, and it's kind of our object that conforms to this. But you could define anything, really, any other type of object. You could have some other type of window delegate. All that it means is I don't care about anything other than the fact that this thing conforms to this NSWindow delegate protocol. And you do that explicitly by putting in the brackets and saying this conforms to that protocol. And then you implement one of the methods that's associated with that protocol. In this case, NSWindow delegate has many optional methods. Most of them are optional. It actually doesn't have any required methods. We won't kind of go into that. That's sort of more of a iOS Objective-C kind of a thing, like required and what's not required. In any case, we implemented one of these. So that's kind of what's going on there. And then we can just set that property. So now we have a window. If we go back and we just save this, and I'm hoping I didn't screw this up, so it's shbuild.sh. Okay, cool. And let's run it. Okay, so we've got our window, right? And now, crucially, I am going to hit the X button. And now, the big thing that's different here, it's going to seem like not that much is different. But if you remember the last time we ran this, I clicked the X button, and this was still running, right? And now what we've actually done is we've got that this Handmade Hero Finish running message is only going to print to the console if we got down here in the code, if we got to line 61. Well, the only way we're getting to like line 61, 62 is if we somehow were able to break out of this infinite loop. And the only reason we were able to break out of this infinite loop is because this global variable running got set to false at some point, which means that we handled this window will close message, or this particular delegate message that's sent from this Handmade window delegate. So we've definitely been able to set that up, and we're absolutely going to be using more of this this window delegate, because closing a window is really, it's not the only thing that we're concerned about here. So it's definitely an important thing to be concerned about, but some of the other ones obviously are going to be window resizing, because there's going to be content inside the game itself that is going to need to kind of respond to somebody deciding to change the size of the window. So that's going to be a really important one, and there may be others. Now this is a application with a window, and it works. We have a window, we can close it. We have a run loop as well. And this is sort of where people kind of come at me with spears and say, oh my God, like, you didn't, because if we look at this, maybe I have that other project. Actually, I don't. I remember when I talked about the auto release pool. So usually, what you would see at the, one of these, you would see an auto release pool kind of encapsulating all of this, right? And so, this is pretty common. Is you wrap everything in an auto release pool. And the reason is because now anything inside of this auto release pool, whenever it gets allocated in the process of running your application, then at the very end it will get deallocated. When the auto release pool automatically releases all of the things that were declared in the inside of it, then they'll get auto released at the end, or they'll get freed at the end, right? Okay, so why are we not doing that? And if this is like a common sort of convention in every kind of a Mac application, the reason we're not doing it is actually pretty simple. We don't need to, at least not now. We might later, but we don't need to for the main application because if you think about it, we're only allocating one thing, the window, right? And that's taking up some memory, sure. We're not allocating anything else though. Like this while loop isn't really doing anything. Like there's nothing that's getting allocated inside of there. So there's really actually no chance for a memory leak if you think about it, because we're only allocating one thing, and then once we exit out of this run loop, at the very end here when we get to this line, then the OS, Mac OS will actually automatically release. It'll free up whatever memory the app was using at the time for us. And so if we were to run this and look at, say, activity monitor, which let's just do that just for funsies, just to see kind of like what I'm talking about. So we got this running, and now I'm going to run activity monitor and just see kind of what is running right now. Okay, and if I can like maybe search for, oh man, I don't know why this is. Okay, Handmade. What's going on? Oh, that's CPU. Okay, not interested. All right, so this just, if we, now some of you are going to be used to using all these fancy tools and all this. Like this is just old school, bare bones, nothing super fancy. All we want to do is just run it and see if the memory increases. Does it increase? Nope. It's just a solid 17.8 megabytes. All right, cool. Then we close it, and now it's not running. So it's not taking up any memory. Like that's kind of what's, so okay, so why do I even bother talking about this? Like what's, why? Well, it's kind of it's a point about, instead of just accepting a convention with this auto release pool, they're cool things to be using when you are worried about memory leaks. But instead of just accepting a convention or just kind of doing it because it's done that way, or like looking at it and saying, oh well, they're doing it this way. But the whole point of making something from scratch, I think, is that we get at these conventions and actually like understand the why of them and program with that understanding, right? It's about not just accepting like these layers and layers and layers and layers of cruft, but maybe questioning some of those layers of cruft and being able to pick apart or remove them, or freely kind of moving about in a space where you have complete understanding of what you're doing, and only proceeding once you have that understanding, and not actually, not just saying, oh well, common wisdom says do this. Another kind of a thing that people are going to come at me with spears is where's the app delegate? Right? Oh my god, like you made an app without an app delegate. What's going on? Well, do we need an app delegate? Frankly, right? We might later, because there's a few different application messages that in terms of how the application looks kind of in the system tray on the bottom, they're important to manage. But oh my, we don't trigger the application did finish launching. Do we need to? We set up our own run loop. Like we know when it finished launching. It finished launching when the frickin' run loop got going. So there's kind of all of these sort of conventions in making an application, things that now, because we're sort of at the level of what we've effectively done. You remember at the very beginning, and I will open it up just because I want to kind of get back to it. So this is where we were at the beginning of this video, is having no view into this main function. Like, what the hell happens here, right? But now we freaking know. Like, now we actually did what is pretty much going on in here, and we've taken control of it. And now we've actually kind of peeked a little bit behind the curtain. We kind of opened it up, and now we can see what's happening in there. We can actually get a little bit of understanding, and that then kind of helps us to understand, okay, what is going on in this application delegate? Like, why does that exist, and who is forwarding those messages to it? in this case, there really is. There's this event loop that's going on, and it's then passing messages to this. So you can't even do this on iOS, by the way. You can't actually. There's no method for this next event. In iOS, if we do decide to do an iOS platform layer for the game, we would actually have to. We'd have to kind of buy into Apple taking control of the main function for us, and there's really no other way to get the event messaging. And I know that kind of sucks, but that is the platform, and that is Apple. It is so funny how it is kind of suffused in every part of Apple's. It's like when you get an Apple computer, you can't look at the hidden files, and you have to enter a terminal command in order to actually see the hidden files. They don't even trust programmers with the event loop. You don't even get to know and it nowadays, if you make a just for posterity, because we have a little bit of extra time, if I were to make a new project, let's say I were to make an iPhone app in Swift, okay, so I'm going to say let's do, just call it Swift app, okay, and the language is Swift, and we'll not use core data or unit tests because I don't want to, and we'll just make this. All right, so what's this going to do? Okay, and this is crazy, there's no files. So, okay, I've got an app delegate. Where's the main function? Where is it, right? You can't see it. And they just don't have a main file. In fact, what they've got is this directive UI application main. This is kind of telling the system to inject that code for the main. So now it's we're not even going to let you know that there was an event loop. We're not even going to let you know that there's this main entry point. It's hiding even more of it from you if it's in Swift. And so it's just kind of something interesting to point out, almost a commentary on the direction that programming is going, at least with respect to Apple, that it seems like we're going in this direction where it's people aren't really, I imagine somebody today could get started with programming and would never, could conceivably start making apps without ever knowing that there is this thing called an event loop, that there's this main function, and that this certain set of things has to happen. And I don't think that's a good thing. And that's kind of part of what this series is about. So by now we're at the end of day 2, and this is I actually haven't written the article yet, but I will for day 3. And I forget exactly. I think by day 3, Casey allocates a back buffer and is able to actually render some kind of output. So I think that's kind of what we'll focus on next, which is going to be really cool, by the way, because that's kind of where that's really where things start to come together, and where where the C and C++ code for the actual game is more or less integrating with the platform layer. So I'm excited to write the article and get doing a video on that. And thanks for watching. If you like, subscribe, comment, etc., etc. Have a great time doing these. So I will see you next time.